Welcome to this new class. This time we're going to be running a lab in which we will deploy OMniLeads using 3 separate Linux instances. The idea behind this proposal is to be able to effectively scale the application and scale the number of concurrent users. A horizontal scalability criterion where we will group the different components of OMniLeads in 3 distinct Linux servers, with, of course, containers or Podman installed. On the one hand, we are going to have the application server, or the Linux instance, where we are going to throw all the containers, all the components that make the web application part. On the other hand, we are going to have a Linux instance where we are going to be executed the 2 components that do the processing of the voice and the part of audio, RTP engine and *1/3 Linux host, where we are going to throw the part of data, Postgres and Redis. In our case, in this lab, we are going to take out the object storage. We are going to continue consuming from the cloud. Yes, but well, in a format is also viable, that MyNeo be installed on a Linux host along with Postgres and Redis. So we have data, boost, and web, where one could also work at the Linux level, at the level of the requirements of the Linux instance. For data processing, where we know that if we are going to run Postgres, for example, we need certain characteristics of the machine. Linux in terms of RAM and I/O speed. Similarly, Asterisk and RTP engines are very CPU intensive. They don't need much RAM, but they require a lot of CPU. For the web, we are also discussing, well, one could tune the requirements of each machine to run web, voice, or data storage. This will allow us to, as I mentioned, separate the components and be able to provide more scalability to the instance. Further, which we are going to explore in another class, the scalability in terms of configuration and tuning over the components. In this case, it is simply open in a horizontal cluster. The installation of Asterisk. So we have 3, now 1 tenant. A tenant, a subscriber, is going to have 3 Linux instances. And that translates beyond the physical instances in the logical part, more precisely in the configuration of the inventory file. The inventory file that we had been managing was in the section of host declaration. We had the part where is I/O instances. That is, what we have here are 3 instances, Pinillo, Tail, and Algarobo. Inno, YAML, is tabular tabulations that are going to be to the hierarchy of objects that we are declaring with their configurations, their attributes. So here in the same hierarchy as I/O instances, I have clusters, instances. And here again, we're going to have a fairly similar format. But now, each tenant, each new subscriber, consists of a block similar to this. Here we have it in another figure. This is O in I/O. Each tenant, each little box, each tenant with its access, consists of tab after I of I/O instancing host, and here start the tenants. While for the part of horizontal cluster, we are going to see that each tenant name is composed of the word host, and it is tabulated. Each one of the Linux instances, of the 3 Linux instances with its variables, for that instance, for that tenant, that compose now a horizontal cluster from application-based OMniLeads, data and voice. Then we will translate this to our inventory file. We're going to translate this to our inventory file. So here, well, I'm going to bring as an example this tenant 5 example. I'm going to move it to Willow. That's what I called it. So now, let's go back. Here, we have the instance. of horizontal cluster, which is called Willow, with its variables. The bottom one I'm not going to use, so I'm going to go clean up here as well. And the part of ha, no, I'm going to leave it like this for now. But well, here I have now my tenant, which is called Willow. This, we're going to take it out. The port part, I'm going to take it out because I'm going to go in through 22. So I'm not going to cite it there. And we're going to pull out all these EPs and 2021 complete with our info from our servers. I'm going to do it in the cloud. So I'm going to delete this part of the LAN as well. And we're going to start putting together our inventory file with the appropriate parameters. So in data, I have an Ubuntu server with this access IP. And this LAN IP for voice, it's the same. For access by private IP. And the application server is the same, IP, private IP. And here, let's fix these SOS. 3 very important variables. On the one hand, I have to have a variable that can be read by all 3 hosts. So this variable is going to affect the tenant, the 3 hosts that make up my subscriber, my tenant. And it is the dial, the data host. The data host is P, land, to reach, to host Linux that's going to have all the data components. More specifically, a Redis, the voice, is voice, asterisk RTP engine, and well for LAN. We are going to put application host is application host. It is the private IP of LAN of the host. Why? Because between these components, here, between these 3 components that make my tenant, have to connect at the networking level. So with that vars statement here, I'm telling data that when it needs to connect to Postgres to do an insert or do a query, it should do it to the data host, which is the private IP of this instance. Here's the app when it has to connect to data. It's going to use this when OMniLeads needs to do a query at asterisk something, and well, it's going to use the voice host. And so between them, we declare where to place each one of them. So here I have Willow. We are going to put one more variable, which is the tenant name. We are going to put bucket name. So this backend name, Willow, and notice that as well as these 2 hosts that I have above, I'm not going to put the bucket URL explicitly down here in my new tenant variables. I'm not going to put nor bucket URL, nor the pair key and access for the bucket. Why? Because I'm going to use the generic, I'm deploying it in the same cloud as these 2 tenants that are already there in DigitalOcean. So here I'm going to use also, if we see in the instances created, I have the 3 instances that are going to compose the 3 Linux hosts that are going to compose my OMniLeads instance for the subscriber. And here, I also have my bucket, Willow. I'm going to do a deploy of 3 Linux instances, a cluster of 3 Linux instances with the external bucket. Why external bucket? Well, because simply down here is affecting all. To all the instances, this parameter, and when this parameter appears like this, without comment, uncommented, is that OMniLeads assumes that all the hosts that have this parameter that is affecting them implies that it is not going to deploy minions 2009. It is going to use just the external bucket that is going to find it in this URL. This URL is affecting all my tenants. I repeat, to the 2 that already had the cloud, plus this new one. This tenant is not affected because I am making explicit that it uses another bucket URL, while this, which is the new one that we are using now, will use the same one. For that reason, simply, I put the name of the bucket and assumes that like these two, it is going to use the bucket URL and the access key, the generic secret key of the general variables. Now, I'm going to go to the last part, to the third section. I'm going to comment this because I am not going to use it, but I am going to uncomment these three. This is the syntax. In the last section of the file, in the third and last section is the part of how I group my hosts to carry forward the actions of deploy. In this case, this is what the 3 instance clusters look like. I could have here now another instance more. That is, I don't know, Aromo, data, Aromo, voice, and Aromo app. And then I would be carrying out an upgrade or an installation from scratch on 6 Linux hosts that are going to compose 2 instances. But well, we are not going to complicate it. We're going to leave simply here a single instance data. Here are all the hosts of the type cluster data, cluster voice, cluster app. As I have only one single subscriber with this installation format, so I have only source data, Willow voice, Willow app. Now that follows install, where about test, qua, that back is the inventory file that exists inside the subfolder T, that is inside instances, that is inside Ansible. Now, if I do an installation, this is going to end up materializing an instance of OMniLeads, which is made up of 3 instances of Linux. There you're accessing data, app and voice, and well, for the most curious ones are going to be seeing how now, in the execution of the tasks of Ansible, we are going to be distributing, or they're going to be distributed. Specific tasks for each type of Linux server. Obviously, when we see that it is deployed, Redis and Postgres, it is going to do it only on the Willow data. While in the sauce voice, it is going to deploy asterisk, and in the sauce up, well, the Phage server, Kamalia WebRTC, let's say, all the most important web part. Well, our cluster has finished the installation of our cluster. Horizontal of 3 components. 3 components to compose an instance of a tenant of a subscriber. I'm going to enter into the app component because the environment initialization or password reset command, I'm going to have to throw it away. Now you have to take into account that each OML manage, for example, to reset password, this command has to be on the web server, on the application server. Same, that the one to initialize environment. So now, yes, I can let's access our instance. Willow, up, 75. Let's throw him a trance party. agent logged in. Well, I would like to, here I am on the application server. On the application server, I have to Camilio here, but Asterisk is on another host. So I would like to do a sngrep just to appreciate this, that, well, we have component distribution. Notice here we have the call leg between an asterisk. This is asterisk. Sorry, this is asterisk 5160, and this camel in the 160. Now if I enter, I'm also going to enter to the component of voice, where RTP engine and asterisks are going to be running. We're going to do a sngret as well, and we're going to see how, well, here we would have to have the call leg. One branch of the call to Camilio and the other branch. There's the two branches. Well, here we have with Camilio, asterisk with the PSTN. If I do a Pogman PS here, I will see that I only have, well, two components plus its metrics exporter for observability. And if now I enter the data component, I should have running only Postgres and Redis since Minho has not been implemented because of Redis server, Postgres server issues. And then we have, well, two monitoring agents of performance. Prometheus Redis, Prometheus Postgres, and well, the node exporter for host metrics. This is already observability. But in terms of OMniLeads components are two Redis. On the other side, we have RT Penguin and asterisks. And here we have the rest of the components that make more to the web application. Fahaji, WebSocket, that would be the asynchronous part of Django. Django with WSGI, Chrome and Nginx. In this way, we have an active cluster of three components well, to be able to boost a little more scalability to the application. Ausend.